Okay, welcome students. Today we're going to be looking at relations and functions. We're going to focus on, well, it's a revision class. So we're actually going to be doing a number of things in the same session. Not to be discouraged though, because we have each of these topics that I'm looking at now. We have videos on all of these subtopics. So if you're still not sure, by the end of the class, and as I go along, you can post your questions and I'll address them right now. If you're still not sure after that, just go to the channel, search our playlist. We have a playlist, we have a graph playlist. All those videos are there. So this is a revision class. Those students who are in chat, just say good morning. Let me know who is here. Let me know who is here. Say good morning. Say present, miss. Say here, miss. Say something. So what we're going to be looking at, we're going to look at the length of a straight line, how to find the length of a line given a point, given 2 points rather. And we're going to look at how to find the midpoint of that line. So the midpoint would be a pair of coordinates that will tell you the position of a point down the line. We're going to look at how to find the gradient, how to calculate the gradient given 2 points. We're going to look at the equation of a line and how to interpret the information given the equation of a line. And then we're going to look at parallel and perpendicular lines and what they say about the gradient of those lines, if they are parallel or perpendicular, and what information we can actually get from them. So it's a mouthful, but as I said, each of topics you can find a separate video on each one if you want to go more in depth with each subtopic. This is a revision class. So we're starting 9, and here we have our coordinate plane. Mine is Lena as well. We're pretending that it is straight. On the coordinate plane, if we have straight line, so that straight line along the plane, give me 1 second, please. Hold on. Hello? Morning. Oh, I'm coming. You can go and fill the form. You have all the document placed already? All right, students, sorry about that. So we have a straight line. What we're really finding when we say the length of the line is how long the line is, right? The actual length. But in terms of the units, centimeter, millimeter, whatever, we don't have to put any units like that. We can just write the word units beside it. So if you look at this line here on the coordinate plane, you realize that we can complete, let me try and be as straight as possible. You all know I have an issue with straight lines. If we complete that and triangle, realize that's a right angle triangle. And if you recall, when we're working with right angle triangles, this half of the line here would represent the hypotenuse of triangle. And the formula for finding the hypotenuse would be to square the two short sides, square each of them, add them, and find the square root. And this is actually what we are going to be doing to find the length of the line. So here's the formula. So let's say this is point A and that's B. So the length of the line, the formula for the length of the line AB, or whichever letters they are, is the square root of, so let me write AB, the length of the line from A to B, the square root of x2 minus x1, which is the second x value minus squared, plus the square root of, sorry, plus this of the y squared. So if you look at it, key is really Pythagoras' theorem. So we're squaring term, or the short side, the side along the x-axis. So the length of here would be the difference between that x value and that x value. So that's what we have in here. And the length of this line would be the difference between the second y value and the first y value. So that's what we have in here. So it's theorem, finding the length of the line is the x value squared plus the y value squared, and we'll find the square root of the sum. So finding the length of the straight line is really Pythagoras' theorem. So let's do an example. So let's say we have a line GH. That's the line. And point G, the coordinate for G would be 4, 2, and the coordinates for H are 4, -2 for G, and the coordinates for H would be, let's say, 3, 5. So these are 2 points, the 2 endpoints of the line. And we want to find the length of the line. So remember, using Pythagoras' theorem is the square root of the square of the x term plus the square of the y term. So it's going to be, so the length of the line GH would be, so we'll go a big square root sign, right? Because we have to work out some difference first. So it will be the second x value minus x value. So that would be 3, 4. And we're going to square it plus the second y, first y value. So that's 5 minus 2 squared. gives us the square root of, so 3 minus 1, right? So that's -1, and we're going to square it. 5 minus -7, and we're going to square that as well. So -1 squared is -1 times -1, which is a +1. 7 squared is 49. So it's the 50. And your calculator, so the square root of 50, and that is 7. And so remember, I said you're going to put, so 7.0, and the word beside it. All right, so here's one for you to try on your own. Give you a little time to work it, maybe 3 minutes. So we have the point D, C. Point D would be -6, -8, and point C would be 0. To work out the length of the line DC, as soon as you're done working out the length of the line, post your answer. So work it out, post your answer. Okay, so work them out quickly, work it out quickly. Let me see some answers coming in now. So remember, we're actually using Pythagoras' theorem. And this is an important, right? So on the coordinate plane, all you have are 2 points. You connect them with a straight line, but you can complete a right angle triangle from that line, just going vertically then horizontally. You will get your right angle triangle, and it's the same concept we're using. A squared plus B squared equals C squared. All right, so let's work it together now. So what we would have for the length of the line DC, so we would put our big square root sign and our brackets, second x value, which is 0, minus the first x value, which is 6, squared, plus the second y value, which is 10, minus the first y value, which is -8, and we're going to square that as well. So what we have here is, this will give a +6, and when we square it, we get 36. 10 minus -8 is 8. And when we square that, we get 324. We add 324 to the 36. We get 360. And the square is 18.97. And that be units. If we were asked to round it to a whole number, so we just say 19 units. So the length of the straight line. Now we're going to look at the midpoint. All right, so Imani got 18.9 units. I'm only seeing Imani's answer. Where are my other scholars? Remember, you're to post your answers so I can see if you're doing the right thing. So the midpoint. So the midpoint of the line would be, as the name suggests, the midpoint is halfway down the line. What we really want are the coordinates of the point. What is the x value? The y value of that point. So if we draw our Cartesian plane again, and if we had a line, so let's say that is the line. The midpoint would be, so halfway down that line, let's say that would be halfway down the line. Extend that a bit so it looks realistic. Halfway down the line would be, we want to know what is the y value there and what is there. That's what we really want to know. What are the coordinates of the y and the x? The formula for finding the midpoint is the first x value plus the second x value divided by 2, and that's for the x coordinate. Sorry. And that's how we get the x coordinate. Comma. For the y coordinate, it's the first y value plus the second y value divided by 2. So let's say we want a line AB, and the coordinate A, let's say that was 5, -12, and the coordinates for point B, -3, and the midpoint, capital M, or you can write out the word midpoint, not to be confused with what we're going to do next, is the gradient, which has a common M representing the gradient. All right, so let's work out the midpoint. So we say for the x coordinate is this value, which is 5, plus the second x value, which is -3. And we're going to divide, this is the midpoint, halfway there. And this y value, -12, plus the y value, which is 4, also divided by 2. There would be 5 minus 3 is 2. 2. And negative is -8, also divided by 2. So finally, what we have is 2 divided by 2, that's 1, and negative divided by 2 is negative. So those are the coordinates of the midpoint, 1, -4. So that means to get to the middle of the line, from the origin, you would move 1 place along the x-axis and 4 places down on the y-axis, and that will give you the middle of the line. Now we're going to look at the gradient, finding the gradient of the line. There is a way you can tell the gradient if you already know the equation of the line. However, that's what we're going to do after this. But if you are given 2 points along the line, you can also find the gradient. And here's so the gradient is represented by an m. And as we'll see when we do the equation of the line, y equals mx plus m is the gradient. Common m. The formula for the gradient is y2 minus y over x2 minus x1. So the second y value minus the first y value divided by the second x value minus the first x value. So if we're given the point x, not use x. If we're given the point r, the line RT, and for point R, the coordinate -5, and for point T, the coordinates are 0 and 3, and the gradient of this line, so the gradient, or m, would be the second y value, 3, minus the first y value, 5, divided by the second x value, which is 0, minus the first x value, which is -11, will give -2 over 11. Right? And that's our -2 over 11. That tells us the slope of the line, how the line is inclined. Now we're going to look at how we can tell the gradient simply by looking at the equation. But tell you what, before I do that, let me go to work on this one. You're going to find, we didn't do any example for this line. So let's say this W P. I want to work out the midpoint gradient. So we have 14, negative, and P is 6, 0. The midpoint and the gradient of this line. And post your answers. Remember, when you're posting your answer, you have to put midpoint equal this, gradient equal that. So let me see your answers. So persons are saying the limit is 10, negative 2.5, gradient negative 5/8. So let's check those. All right, so for the midpoint, let me different color. For the midpoint. Okay, so for the midpoint, like we said, that was x1 plus x2. So for the x coordinate, it's x1 plus x2 divided by 2. So that would be 14 plus 6. So 14 plus 6 by 2. And for the y coordinate, it would be negative 5 plus 0. Also divided by 2. So that would give us 14 plus 6 is 20. And we're going to divide that by 2. Negative 5 plus 0 is 5. And divide that by 2. So the final answer would be 10, negative 2.5. All right. So all those who had that, you are correct. All right. So that's 10 and negative 2.5. All right, so for m, remember m represents gradient. So y2 minus, so that's the second y value minus the first y value over second x value minus the first x. So that gives negative 5 over 6 minus 14. So that's 8, negative 8. So that's negative 8. Negative 5/8. Let me see if I can do better with this. Okay, so negative 5/8. All right. So let's move on now to the equation of a line. The equation of the line is y equals mx plus c. That's the standard equation of a straight line. Y equals mx plus c. So once the equation is in this format, there are a number of things you can tell about the equation. One thing you can tell is the y-intercept. Another thing you can tell is the gradient of the line. So C tells us the y-intercept, or where the line crosses the y-axis. M, or the number, coefficient of the x, the number that's in front of x, tells you the gradient. So just by looking at the, you can tell these two things. You can the y-intercept, and you can tell the gradient of the line. For example, if we have y equals negative 2x plus, the gradient negative 2, and the y-intercept is 9. So that line is negative, and the line will cross the y-axis at equal to 9. If we have a line y equals 4x minus 6, the gradient is 4, and the line will cross the y-axis at negative 6. So these are things that we can tell about the line just by looking at the equation of the line. All right, what I think I'm going to do is we're going to have another session, another time, and go deeper into the equation of the strain, as well as to look at the parallel and perpendicular lines, what we can tell given knowing their gradients, how we compare their gradients, and defining solutions for problems relating to parallel and perpendicular lines. So we're going to wrap up this session now. And when we have our next session on relations and functions, we continue our revision of the equation of the straight line and perpendicular line.